This is the EdExcel GCSE 91 Maths Higher Paper 1 from the November 2020 series, and this paper is a non-calculator paper. Question number 1. The first 5 terms of an arithmetic sequence are 1, 4, 7, 10, 13. We have to write down an expression in terms of n for the nth term of this sequence. We begin by finding the difference between each term. The difference between each term is positive 3. And so therefore, the coefficient of n will be 3. And to find the 0th term, we have to perform the inverse operation of plus 3, which is subtract 3. 1 subtract 3 is negative 2. So the nth term is 3n minus 2. Question number 2. We have to show that 2 1/3 multiplied by 3 3/4 is equal to 8 3/4. So, beginning with the result on the left hand side, if we convert these mixed numbers to top-heavy fractions, well, we've got 2 multiplied by 3 plus 1 divided by 3 being multiplied by 3 multiplied by 4 plus 3 divided by 4. So, if we attempt to simplify this even further, 2 times by 3 is 6, plus the 1, that's 7. So we have 7/3 being multiplied by, well, 3 times by 4 is 12, plus another 3, that's 15. And then we divide by 4. So we have the calculation 7/3 multiplied by 15/4. Now, you will recognize that 15 divided by 3 is 5. So the result simplifies to 7 multiplied by 5/4. And this is the same as 35/4. Now, how many times does 4 go into 35? Well, it goes in there 8 whole times. And what will be left over is 3. So 2 1/3 multiplied by 3 3/4 simplifies to 8 3/4. Question number 3. The diagram shows 4 graphs. We've got graph A, graph B, graph C and graph D. Each of the equations is in the table is the equation of one of the graphs. We have to complete the table. Well, if we take a look at graph A, this is the graph of y equals 1 over x. So here we have graph A. If we take a look at graph B, well, this is similar to the graph of C. However, C is positive x cubed, B is negative x cubed. So we have the graph B being y equals negative x cubed, the graph C being positive x cubed, and the graph D then is a quadratic, y equals x squared. Question number 4. The diagram shows four triangles. That's what we see here. We've got triangle A, B, C and D. Two of these triangles are congruent. We have to write down the letters of these two triangles. Well, here we've got a 55 and a 45. We've got two angles given. For D as well, we've got two angles given. What we can do is find out the missing angle in both of those. 180 take away 55 take away 45 is 80. So I've got 80 degrees over here. And if I take a look at triangle D, 180 take away 80 take away 45 is 55. So I've got 55 degrees here. Now, it then becomes more obvious how to spot which triangles are congruent. Well, of course that will be A and D because I've got the 10 here. I've got 10 here. I've got 55 here. 55 here. And I've got 45 here. And I've got 45 here. And so we can conclude the triangles A and D are congruent. Question number 5. Sean pays £10 for 24 chocolate bars. He sells all 24 chocolate bars for 50p each. We have to work out Sean's percentage profit. Well, let's see how much he sells all the chocolates for. We've got 24 chocolates. They are 50p each, in other words, £0.50. So all of his selling sells them all for £12. We can now find the overall profit. The overall profit is equal to £12, subtract the £10, which is what he pays. His overall profit is £2. And so therefore, his percentage profit is equal to 2 divided by 10 multiplied by 100. Of course, we have 20% as the percentage profit. So we have 20% for the overall percentage profit. Question number 6. ADC is a triangle. AED and ABC are straight lines. EB is parallel to DC. The angle EBC is 148 degrees. The angle ADC is 63 degrees. We have to work out the size of the angle EAB. You must give a reason for each stage of your working. Well, we are giving this 148 degrees, which is the angle EBC, and with this we can find the angle ABE. The angle ABE is equal to 180, subtract the 148, which is equal to 32. So the angle here is 32 degrees. And that's because the angles on a straight line add up to 180. The angle over here is equal to 63 degrees. We can spot that because we've got corresponding angles. We have this straight line, and then we've got the two parallel lines over here, which means this is 63 and this is 63. So the angle AEB is equal to the angle EDC, which is equal to 63, because we've got corresponding angles. We can now find out the missing angle here, which is the angle we require. The angle EAB is equal to 180. Subtract the 63, subtract the 32, which is equal to 85. The angle here is equal to 85 degrees, and that's because angles in a triangle add up to 180. So the angle adds up to 180 degrees, which is this angle here. Question number 7. The table shows information about the heights in centimetres of a group of Year 9 girls. We've got the least height, the median and the greatest height being in centimetres 150, 165 and 170. We've got this stem and leaf diagram which shows information about the heights in centimetres of a group of 15 Year 9 boys. We've got this key here, 15 with this line, and then the 8 represents 158 centimetres. We have to compare the distribution of the heights of the girls with the distribution of the heights of the boys. Well, what we can do is find out the range with the girls. The range is equal to the largest value, 170, subtract the smallest value, 150. So it turns out the range is 20 centimetres for the girls. And we know that the median is already given to us for the girls as 165 centimetres. Now we can find the median for the boys and also the range for the boys. So the median and the range, well, let's start off with the median. We want the 15 plus 1 divided by 2, so we want the 8th value. The 8th value is 168. So the median, we'll call it Q2 for a sec, is equal to 168 centimetres, and the range is equal to the largest value, 182, subtract the smallest value, 158. It turns out the range is 24 centimetres for the boys. So what we can now do is compare the distributions. Let's first of all take a look at the median and then the range. So the median for the girls, which is 165 centimetres, is less than the median for the boys, which was 168 centimetres. So the range for the girls, which is 20 centimetres, is less than the range for the boys, which is 24 centimetres. Question number 8. The diagram shows a prism placed on a horizontal floor. The prism has a height of 3 meters and the volume of the prism is 18 meters cubed. The pressure on the floor due to the prism is 75 newtons per square meter. We have to work out the force exerted by the prism on the floor. We know that pressure is equal to force divided by area. So we need to find the area. Well, we've got a volume and we've got a height. We can find the area of the base. Area of the base, which is shown shaded here, we've got 18 meters cubed, and then divided by 3 meters, so we get 6 meters squared as our area. Now we know that the pressure is 75, so we have 75 equals force divided by the area, which is 6, and therefore the force is equal to 75 multiplied by 6, which is 450. We've got 450 newtons as our force. Question number 9. We have to write these numbers in order of size. Start with the smallest number. Well, what we will do is rewrite all of these numbers in standard form. And just to remind you, standard form is when a number is written as a times by 10 to the power of n, where a is in between 1 and 10. Now, the result here is already in standard form, but the result here, if we use the balancing method, if I divide the 67.2 by 10, I need to multiply the 10 to the minus 4 by 10. So this value is the same as 6.72 multiplied by 10 to the minus 3. And the value here, 672 times 10 to the 4. If I divide by 100, I need to multiply the 10 to the 4 by 100. So this is the same as 6.72 times 10 to the power of 6. And the value here, well, if I move the decimal place 1, 2, 3, 4 to the left, rather 4 to the right, then this is the same as 6.72 times 10 to the minus 4. So which one is the smallest? Well, it will be this, followed by this, followed by this, followed by this. So writing the original numbers, we've got 0.00672 followed by 67.2 times 10 to the minus 4 followed by 6.72 times 10 to the power of 5 followed by 672 times 10 to the power of 4. Question number 10. We're given that A over B is equal to 2/5 and B over C is equal to 3/4. We have to find the ratio of A to B to C. Well, from here we can see that the ratio A to B is equal to 2 to 5. And if we take a look at the ratio here, B to C, that's equal to 3 to 4. Now the idea is to get the B's the same, and that allows us to find the ratio A to B to C. Now if I've got 5 here and 3 here, the lowest common multiple of 5 and 3 is 15. So if I have a 15 here and here, then to go from the 5 to the 15, I multiply by 3, and then from the 3 to the 15 I multiply by 5. So I need to multiply 2 by 3 to get 6, 4 by 5 to get 20, and from that we can conclude A to B to C is equal to 6 to 15 to 20. So we've got 6 to 15 to 20. Question number 11. We have to find the value of the fourth root of 81 times 10 to the power of 8. Well, here we need to use the rule a to the power of m, all raised to the power of n, is a to the power of m n. So we have 81 times 10 to the power of 8, which is equivalent to 81, rather, raising something to the power of a quarter is the same as taking the fourth root. And then each bit inside the bracket is raised to the power of a quarter. So I've got 81 to the power of 1/4 multiplied by 10 to the power of 8 to the power of 1/4. 81 to the quarter is 3, and then here I multiply the powers according to this rule, leaving me with 10 to the power of 2. 3 times 10 to the power of 2 is 300. I end up with 300. For part B, we have to find the value of 64 to the power of -1/2. Well, what this is the same as is 1 over 64 to the power of 1/2, and this is equal to 1/8. So we are left with 1/8. For part C, we have to write 3 to the power of n divided by 9 to the power of n minus 1 as a power of 3. Well, here we need to use the rule a to the power of m divided by a to the power of n equals a to the power of m minus n. When dividing with the same base, we subtract the powers. Now, if I have 3 to the power of n, then 9 is the same as 3 squared, and then I raise this to the power of n. Now if I multiply the powers according to the rule that we mentioned before, we've got 3 to the power of n divided by 3 to the power of 2n minus 2, and then if I subtract the powers, I've got 3 to the power of n subtract 2n minus 2, and it turns out we get 3 to the power of 2 minus n. So I am left with 3 to the power of 2 minus n. Question number 12. The table gives information about the weekly wages of 80 people, and for part A we have to complete the cumulative frequency table. Well, we start off with 5, and then we've got 5 plus the 10, which is 15. 15 plus 20 is 35, plus another 20 is 55, plus another 15, that's 70, plus another 10, that's 80. Here is the completed cumulative frequency table. For part B, we have to, on the grid opposite, draw a cumulative frequency graph for your completed table. Here is our cumulative frequency grid, which is not filled in, so we have to fill it in. So we've got 205, which is here. Then we have 200, then we've got 255. Then we've got 350, 35. 315 first. Then we've got 350, 35. And then we've got 455. Then we've got 450, 70, which is here. And then we've got 580, which is over here. And then we connect all these with this smooth line. So here is our cumulative frequency graph. Now for part C, Juan says 60% of this group of people have a weekly wage of £360 or less. Is Juan correct? You must show how you get your answer. Well, first of all, 60% of 80, that's equal to 48. So if I go back here, 48 is over here, draw a line across, and then drawing a line down from here, we've got a value of roughly 380. The value here is around 380. So this corresponds to a wage of 380. Now, because this doesn't equal the 360, which is what's mentioned here, we can therefore conclude that Juan is incorrect. Question number 13. Liquid A and liquid B are mixed to make liquid C. Liquid A has a density of 70 kilograms per meters cubed. Liquid A has a mass of 1,400 kilograms. Liquid B has a density of 280 kilograms per meters cubed. Liquid B has a volume of 30 meters cubed. We have to work out the density of liquid C. So, the first thing we can do, given information about the density and the mass, is find out the volume of A. So, the volume of A, that will equal 1,400 kilograms divided by 70 kilograms per meters cubed. So it turns out the volume of A is 20 meters cubed. We know the volume of B, and so if we add the volume of A to the volume of B, we can find the volume of C. So we've got 20 meters cubed, which is A, plus 30 meters cubed, which is C. It turns out here we get 50 meters cubed. So what we can do now is find the mass of B. To find the mass of B, that will equal 280 kilograms per meters cubed multiplied by the volume 30 meters cubed. It turns out here we get 8,400 kilograms for the mass of B. And so we can find the mass of C by adding together the mass of A, 1,400 kilograms, with the mass of B, 8,400 kilograms. So the mass of C is 9,800 kilograms. And so therefore for the density of C, we have the mass 9,800 kilograms divided by the volume 50 meters cubed. So the density is equal to 196 kilograms per meter cubed. Question number 14. Sally plays 2 games against Martin. In each game, Sally could win, lose or draw. And in each game they play, the probability that Sally will win against Martin is 0.3. The probability that Sally will draw against Martin is 0.1. We have to work out the probability that Sally will win exactly one of the 2 games. To do this question, I think it will be a good idea to draw a tree diagram showing the different outcomes to begin with. So here we've got a tree diagram showing our different outcomes now. Before we do anything else, we can find out the probability that we lose a game. That's equal to 1 minus the 0.3 minus the 0.1, which is the 0.6. Now we want to win exactly once. So for us to win exactly once, we could win and draw, or we could win and then lose, or we could draw and win, or we could lose and then win. So therefore, the probability that we win exactly once, that's equal to the probability of winning and then the probability of drawing. Then we've got the probability that we win and then the probability that we lose, and then we've got the probability that we draw followed by the probability that we win, and then we've got the probability that we lose followed by the probability that we win. Now we know that the probability that we win is 0.3 and draw is 0.1 and lose is 0.6. So we've got 0.3 multiplied by 0.6 plus 0.3 multiplied by 0.1 plus 0.1 multiplied by 0.3 plus 0.6 multiplied by 0.3. And if we work all of this out, it turns out we get 0.42. So the probability that we win exactly once is 0.42. Question number 15. The straight line L1 has equation y equals 3x minus 4. The straight line L2 is perpendicular to L1 and passes through the point 9,5. We have to work out an equation of the line L2. First of all, equations of straight lines are in the form y equals mx plus c, where c is the gradient. Now if I take a look at the line L1, the gradient is quite visible, that's just 3. And so therefore the gradient of L2, that will equal the negative reciprocal of 3, which is minus 1/3. And so using the point 95 and substituting into y equals mx plus c, we've got y, which is 5, equals m, which is minus 1/3, lots of x, which is 9, plus c. 5 equals negative 3 plus c. C is equal to positive 8. And therefore y is equal to minus 1/3 x plus 8. So we've got y equals minus 1/3 x plus 8 as our equation of the straight line. Question number 16. Shirley wants to find an estimate for the number of bees in her hive. On Monday she catches 90 of the bees and she puts a mark on each bee and returns them to her hive. On Tuesday she catches 120 of the bees. She finds that 20 of these bees have been marked. For part A, we have to work out an estimate for the total number of bees in her hive. Well, if we let n equal the total number of bees in her hive, well, let's think about what's happening on Tuesday. We've got 120 bees, and of those 120 that she catches, 20 of them have a mark. And the result over here will be in proportion with the total number of bees we have, n. Now, if on Monday she catches 90 of the bees out of a total of n, then quite simply 90 over n is equal to 120, is equals 20 over 120. So we've got 90 divided by n equals 1/6, from which we can see, if I multiply by n and then multiply by 6, n equals 90 multiplied by 6, which is 540. But now for part B, Shirley assumes that none of the marks had rubbed off between Monday and Tuesday. If Shirley's assumption is wrong, we explain what effect this would have on our answer to part A. Well, there will be fewer bees. Question number 17. We have to make f the subject of the formula d equals 3 multiplied by 1 minus f divided by f minus 4. Well, if I multiply through by f minus 4, then we would have d multiplied by f minus 4 equals 3 multiplied by 1 minus f. Then we have df minus 4d equals 3 minus 3f. Everything with a d on, everything with an f on one side, everything that's not an f on the other. We've got df plus 3f equals 3 plus 4d. And if I factorize on the left, I've got f lots of d plus 3 equals 3 plus 4d. And if I divide through by d plus 3, then f is equal to 3 plus 4d divided by d plus 3. So our formula for f is 3 plus 4d divided by d plus 3. Question number 18. X is proportional to the square root of y, where y is greater than 0, and y is increased by 44%. We have to work out the percentage increase in x. Well, if x is proportional to y, we can say from here then, x is equal to k multiplied by the square root of y, where k is a constant. Now, after the increase, we have x equals k multiplied by 1.44y. And the reason for this is because y has increased by 44%. So, y has increased by 44%, which is what we see here. So we've got x equals k multiplied by 1.44 square rooted multiplied by y square rooted. So we've got x equals 1.2k, square root of 1.44 is 1.2, multiplied by y. So what's the percentage increase in x? Well, as a multiplier, we'd have 1.2, so we have an increase then of 20%. Question number 19. F and g are functions such that f of x is equal to 12 divided by square root x, and g of x is equal to 3 multiplied by 2x plus 1. We have to find g of 5. Well, g of 5 is equal to 3 multiplied by 2 times by 5 plus 1, which is equal to 33. So we have 33. Next, for part B, we have to find g of f of 9. Well, first of all, let's find out what f of 9 is. F of 9 is equal to 12 divided by the square root of 9. 12 divided by 3 is 4. So f of 9 is equal to 4, and therefore g of f of 9 is equal to g of 4. So we have 3 multiplied by 2 times by 4 plus the 1, which is 27. For part C, we have to find g inverse of 6. Well, g inverse of 6 is the same. Well, rather, g of inverse of 6 implies that we are solving the equation g of x equals 6. So, with that in mind, we have 3 multiplied by 2x plus 1 equals 6. We are finding out what x is. Dividing through by 3, 2x plus 1 is equal to 2. 2x is 1. X is equal to 0.5. So I have 0.5. Question number 20. We have to show that the square root of 180 minus 2 times the square root of 5 divided by 5 square root 5 minus 5 can be written in the form a plus square root 5 over b, where a and b are integers. First of all, we can simplify the square root of 180. This is the same as the square root of 36 multiplied by the square root of 5, which is the same as 6 times by the square root of 5. So we can rewrite the result over here as follows. We've got square root 180, which we've just said is the same as 6 times by square root 5, and then we subtract 2 root 5 divided by 5 times by the square root of 5 subtract 5. So on the top we've got 6 root 5 minus 2 root 5, which is 4 root 5. And on the bottom we've got 5 root 5 subtract 5. Now what we need to do is multiply the top and bottom by the conjugate of the bottom. So we need to multiply the top and bottom by 5 times by the square root of 5 plus 5 over 5 times by the square root of 5 plus 5. It's as though we are multiplying through by 1. So let's work all of this out. What we have here, 4 root 5 times by 5 root 5, well 4 times by 5 is 20, and then root 5 times root 5 is 5, and then we've got 4 root 5 times by 5, that's 20, root 5. And then on the bottom we've got a difference of 2 squares. 5 root 5 times 5 root 5 is the same as 25 times by 5, and then 5 root 5 times by 5 is 25. So what do we get over here? When we simplify all this, 20 times by 5 is 100, and then I have 20 root 5, and on the bottom I've got 125 minus 25, which is 100. So if I continue to simplify all this, we've got 100 over 100 plus 20 root 5 over 100, which simplifies to 1 plus root 5 over 5. And that's exactly what we wanted to show. Question number 21. DEF is a triangle and P is the midpoint of FD and Q is the midpoint of DE. FD is A and FE is B. We have to use a vector method to prove that PQ is parallel to FE. Well, if P is the midpoint of FD, that means FP is equal to PD, which is equal to 1/2 FD, which is equal to 1/2 of the vector A. So we have a vector here and a vector here, which are both equal to 1/2 A. So those are what we found so far. And now we can, well, if I add on information about FE, FE is equal to the vector B. And what we can now find out is what the vector DE is. The vector DE, starting at D, finishing at E, that's the same as DF plus FE. So we've got DF, which is minus A, plus the vector FE, which is B. And knowing that Q is the midpoint, then DQ is equal to QE, which is equal to 1/2 of the vector DE, which is equal to 1/2 of minus A plus B, which is the same as 1/2 B minus 1/2 A. And what we can also find is the vector PQ. So we can find the vector PQ, which is the vector here. Well, first of all, DQ is 1/2 B minus 1/2 A. So that is this and this. So that's what the vector DQ and QE are. So therefore the vector PQ is equal to the vector PD plus the vector DQ. So the vector PD, going from P to D, that's 1/2 A. And the vector DQ is this vector here. And it turns out we get 1/2 A minus 1/2 A, which is 0A. And then we also have the 1/2 B. And if I add this to my diagram, I've got a 1/2 B. You can see those are multiples of each other. So we can conclude that the vector FE is equal to twice the vector PQ, from which we can conclude PQ is parallel to FE. Question 22. The diagram shows two shaded shapes A and B. Shape A is formed by removing a sector of a circle with radius 3x minus 1 from a sector of the circle with radius 5x minus 1 Shape B is a circle of diameter 2 minus 2x, and the area of shape A is equal to the area of shape B. We have to find the value of x. You must show all of your working. Well, first of all, we've got this large radius, 5x minus 1, and we've got the radius of the smaller circle, 3x minus 1, and then here we'd have a length of 2x. 5x minus 1 subtract the 3x minus 1 gives the 2x. We've got this diameter of 2 minus 2x, and from that you can see the radius will be half the diameter, 1 minus x. Now, how do we find the area of a sector? Well, that's given by the formula theta divided by 360 multiplied by pi r squared. So if I take a look at shape A, we have the angle 45 divided by 360 multiplied by pi multiplied by, well, the radius squared here, we've got the larger sector subtract the smaller sector. So what we can do here is find the difference between those. We've got r squared as the radius of the sector. We've got the larger sector, 5x minus 1, and then we square this. And then we've got the smaller sector, 3x minus 1, all squared. And hopefully here you can recognize how this formula here gives us the area. Now, 45 divided by 360, that's an eighth, and I multiply that by pi. So I've got pi over 8 multiplied by, well, 5x minus 1 all squared. That's the same as 25x squared minus 10x plus 1, and then I subtract 3x minus 1 all squared, which is the same as 9x squared minus 6x plus 1. So I'm left with pi over 8 multiplied by, well, here 25 minus 9 is 16, so I've got 16x squared. Then I've got minus 10x minus 6x, so that's minus 10 plus 6, which is minus 4. And then I've got the x, and then the 1 and the minus 1 give 0. So that's the area of A. Units, of course, we've got centimetres squared. The area of B, that's the area of a circle. We've got pi r squared. I've got pi multiplied by the radius, which is 1 minus x, all squared. So working this out, I've got pi multiplied by x squared minus 2x plus 1. That's the area of B. And because those are equal, we can say then that the pi over 8 multiplied by 16x squared minus 4x is equal to pi multiplied by x squared minus 2x plus 1. And you'd find the pi's cancel, and if I multiply by 8 on both sides to get rid of this fraction, we'd have 16x squared minus 4x equals 8x squared minus 16x plus 8. And if I rearrange to get everything on one side being 0, you will find we have 8x squared plus 12x minus 8 equals 0, and at this point, if I divide through by 2, rather divide through by 4, then we have 2x squared plus 3x minus 2 equals 0, and attempting to factorise, I've got 2x minus 1 multiplied by x plus 2 equals 0, from which we can see either x is equal to 1/2, or I've got x equals minus 2. Now, as x must be greater than 0 because we've got a length, we can see then that x equals 1/2 is the only solution. Question number 23. There are 4 types of cards in a game. Each card has a black circle or a white circle, or a black triangle or a white triangle. The number of cards with a black shape to the number of cards with a white shape is 3 to 5, and the number of cards with a circle to the number of cards with a triangle is 2/7. We have to express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. Well, from these ratios, from the first ratio, we can see that the fraction of shapes which are black, well, I've got 3/8. That's the fraction of shapes which are black. What I can now do is find out the fraction of shapes which are triangles. That will equal 7/9. I've got 7 out of 9. And so therefore, what I need to do is work out the total number of black shapes as a fraction of the total number of cards with a triangle. So I need to express 3/8 as a fraction of 7/9. And so what this is the same as is working out 3/8 multiplied by 9/7. And continuing on with this, 3 times 9 is 27. 8 times by 7 is 56. So I end up with 27 over 56 as my required fraction. So we end up with 27 over 56.